Hello students, this is Mrs. Crumpton. Today's math lesson is on section 8.5 using the distributive property from your Glencoe Algebra 1 book. Your learning target: I can use the distributive property to factor polynomials. I can use the distributive property to solve equations of the form ax squared plus bx equals 0. Previously we have used the distributive property and we have multiplied that, and we said that the parentheses are like a house, and you multiply what's inside that house by everything, or you multiply your hugs, you are the term outside parentheses, and we multiply our hugs by everybody inside the house. So this time we're going to take our hugs back and go out the door, which kind of what I'm talking about there is factoring. Factoring is to express a polynomial as the product of monomials and a polynomial. So all you're really doing is undistributing. That's another way to look at factoring. To factor by grouping is using the distributive property to factor 4 or more terms, and we'll look at that in just a few minutes. The zero product property: if the product of two factors is 0, then one of the factors must be 0. Please be sure you pause the video if you need some extra time to write these definitions, your learning target, and your lesson title, and make sure you get those written down. Students, we're going to look at our first example here using the distributive property, and like I told you, we're actually going to be undistributing instead of distributing. Okay, take a look at this example here. What you've got to do is you've got to find the greatest common factor. Now, if you don't like the way, or you don't really understand the way that I'm going to show you how to do this, be sure you check out your example on page 495 of your textbook, because they show it a little differently from how I'm going to teach it. And you might understand that way a little bit better than what you understand my way. Now, I look at this and I'm thinking, okay, the coefficients, 15 and 25. What is the largest number that will divide evenly, or what is the largest factor, greatest common factor, of both of these numbers? Well, that greatest common factor here for those coefficients is 5. Okay, now I've got to look at the x and the x squared. What is the greatest common factor of both of these variables? Well, x will divide into itself evenly, and x will divide into x squared 2 times. But I only have one x in common, so my greatest common factor here between the variables would be x. Because I have one x here, 2 x's here, there's only one x in common. So now I'm going to come back over to my problem, and I'm going to write that 5x outside of parentheses. Now I want you thinking, before when I did these, I was hugging everybody in the house. Parentheses being the house. This time I'm taking my hugs and running out the door, or I'm factoring, or I'm undistributing, whichever way you'd like to say it. So what did I multiply times 5x to get 15x? Think on that for just a second or two before I tell you the answer. You should have it by now, because 5 times what gives you 15? 3. And of course x divides into itself one time evenly, so if I multiply this back out, we'll see in just a minute on the check, you get 15x. Now, I want you thinking here, what number can I multiply by itself, or excuse me, I just gave you the answer. What number can I multiply 5 by to get 25? Of course, that is 5. And x times what gives you x squared? Well, that would be x. That is your factored answer. We have factored that polynomial. Now to check the answer, all we're going to do is we're going to use that distributive property like we did many moons ago to see if we get what we started with. And yes, I know I ended that sentence. I think that's a preposition. So English folks, y'all just forgive me. 5x times 3 would be 15x. 5x times 5x, 25x squared. I got my original problem, so I know that this answer is correct. Okay, think on that for just a minute. Make sure you get your example down, and I'll come back with a second example in just a minute. Next, I'm going to show you an example for factoring by grouping. This key concept is on page 495 of your textbook. So if you don't have time to get it now, make sure you go back and look at that and get it sometime in your notes. Students, next we're going to factor a polynomial by grouping. Now that was the key concept that I just showed you. To factor by grouping means that we may have to rearrange some stuff. And remember that we can rearrange stuff using the commutative property. So it's okay, but just don't lose the signs of numbers or terms along the way. For this problem, to factor by grouping, what I want to do is I want to arrange these coefficients or rearrange the terms by commutative property in a way where I can undistribute some more things. So let's look closely. Here, these first two terms, I could factor out an x. Now, that's okay, but I think I see something else that I might could do. With these last two terms, I really don't have anything in common but a negative 1. So here's what I think I want to do. I want to take these two terms and use our good friend Mr. Commutative property and rearrange. It's perfectly legal to do this. I'm not going to send you to math jail. Just don't lose your signs on the way. Okay, take a look here. Now, this is looking a little better because now I've got my coefficients right next to each other, like coefficients, sort of like coefficients. That one's negative. But I can factor that 2 out. In addition to factoring a 2 out, I have a y in common. So I can factor out a 2y from the first two terms and group these two terms together. Of course, when I divide or factor or undistribute, 2xy divided by 2y leaves me with x. Negative 2y divided by 2y leaves me with negative 1. And then I am going to factor these two terms. Well, that's looking a little bit easier to factor too, because now I have a 7 and a negative 7 in common. I can factor out a 7. Now I've got a plus sign here, so I don't want to lose that plus sign. If I were factoring out a negative number, I would do something a little differently, but we'll probably see an example like that in a minute. So I'm going to factor out now the 7. And I'm left with x minus 1 inside the parentheses. Take a look at this. Do I have something else that I can factor? Do I have another greatest common factor? Look closely. I actually do. Now I have x plus 1 and x plus 1 that I can factor out, undistribute, unhug. So if I factor out this x minus 1, what I'm going to have left behind, or what I factored in, would be 2y plus 7, close parentheses. Now I'm going to leave this one to you. You can use FOIL, you can use distributive property, or you can use the Punnett square. Try these and see if you get what you started with. If you did, now the terms might be in a little different order, but as long as you get what you started with, you know you factored correctly. Pause the video now if you need to make sure that you get this example in your notes. Here's another example for you of factoring by grouping. Take a look at this problem. Do I need to rearrange? Do I have coefficients that will factor? Do I have variables that will factor? Look real closely at this. If I want to factor this one by grouping, I could actually group these first two terms together as they are. 3 is a factor of 15, and A is a factor of itself. So I can actually factor out 3A. Undistribute, or factor, or divide 15A by 3A, and that gives you 5. Dividing negative 3AB by 3A leaves you with B. Now if you have questions about this, be sure you bring those questions to class so we can take care of them. Next, I'm going to group this next two terms together. What do I have in common? What is my greatest common factor of the coefficient and the constant? 4 is my greatest common factor. Now I'm going to multiply or divide, and I would have B minus 5. Take a look at this problem. Think about it for just a second. Can I factor any more like the problem is? I can't. But if I go back to this pair that I grouped together, and instead of factoring out a 4, what if I factor out a negative 4? Is that going to change the way I work the problem? Now that I factored out a negative 4, here, that would leave me with negative B. Factoring out a negative 4 from 20 would leave me with a positive 5. Hey, you know what? I could rewrite this using commutative property, going way, way back. And look, I got something else I could factor. This is alike. This is alike. So that's my GCF, greatest common factor, still. So now I can factor out 5 minus B, and I've got 3A minus 4 that I grouped together. And this is my factored form of this polynomial. Factor by grouping. Now I'm going to leave this to you. You FOIL it out. See if we have the right answer. If I don't, make sure you tell me in class so we can work on it and correct. In the previous examples, we have been looking at expressions. Now we are going to look at solving equations. A little bit different, but we are still going to think about factoring as we do this. Now this actually is pretty easier. It's a lot easier than some of the other equations that you solved. What I'm going to do is I'm going to separate this out into two problems. I'm going to take this part, x minus 2, set it equal to 0, and solve. I'm going to take the second binomial, 4x minus 1, set that equal to 0, and solve. Pause the video, take just a minute or two and see if you remember how to solve a one-step and a two-step equations. Probably in the time that I'm talking, some of you already have both of these solved. So I'm just going to jump right in. X equals 2 here. Now if you don't understand how I did this, be sure that you ask me. Take a look, make yourself some notes. Here's the thing, this says check your solution. So you need to go back and plug in. My answer here for this problem is x equals 2 or 1/4. So make sure you check your solution on these. When I replace x with 2, I have 2 minus 2, 4 times 2 minus 1. Does that equals 0? Look back at that zero product property for just a minute that I gave you at the beginning of the video. And it says in that zero product property that if you've got the product of two numbers and the answer is 0, that one of the factors must be 0. Well, let's see if this is going to work out. 0. Well, I already think that one's going to work out. 0 times 8 minus 1, does that equal 0? Well, 0 times anything is 0. So, the 2, we know for sure, is an answer. Okay, this is getting kind of messy up here, so I hope you got this. I'm going to erase that real quick, and we are going to replace into our original equation with 1/4. So I've got 1/4 minus 2, and 4 times 1/4 minus 1 equals 0. Okay, I know you all well enough. You are looking at this and saying, I don't know how to do that. How do I do it? Here's what I'm going to do. Take the easy road first. Come over here. I've got reciprocals of each other. When I multiply the reciprocals, 4 over 1 times 1 over 4, my answer here is going to be 1. So in this second grouped, second binomial, or second group of terms, I've got 1 minus 1. That equals 0. So guess what? In your check, if you can't do 1/4 minus 2, first off, you got to learn how to do that, because sometime or other you're going to need to know that. But for short-term purposes, it doesn't matter what this equals, because anything times 0 is 0, so my 1/4 checks out, and that is your answer. Different from the previous example that I showed you. 4y equals 12y squared. Well, to solve this, I really need something to equal 0, and I got no 0 here. So how about if I try something here? What about if I subtract 4y from both sides? What happens here? Adds out to be 0. What happens here? Is the answer to that 8y squared? No, it's not, and you know it's not, because these aren't like terms. I keep both terms. Okay, now, greatest common factor. Do I have one? You better say yes. My GCF here. Coefficients, I can factor out 4 my variables, I can factor out a y. So I got 0 equals 4y. 4 divided into 12y squared, or undistributing, would be 3y. 4y goes into 4y one time. Now then, same thing I did in the previous problem since I've got it this far. I'm going to say 4y equals 0. And I'm also going to say 3y minus 1 equals 0. Solve this. Well, if I divide 0, not by 0, by 4, I get y equals 0. Now we can have a 0 in the numerator, but we cannot have a 0 in the denominator. Why not? Why not? Division by 0 is undefined. Don't forget that. Important. Okay, here, two-step equation. So y equals 1/3. Now in the previous example, I showed you how to check these and make sure that you have a correct answer. This time, I'm going to let you perform the check on your own to make sure that we have a correct answer. Your answer is 0 or 1/3. Perform your check, see if we're right. It's assignment time, students. The first part of your assignment will be a formative assessment of 4 problems from page 497. Those 4 problems are problems 3, 5, 11, and 13. Your assignment, which will go over the formative assessment problems in class. If you have questions, we'll take a look at those. You can go ahead and start your assignment from pages 497 and 498. Problems 14, 19, 20, 21, 27, 33, 37, 39, 41, and 45. Thanks so much for watching the video, and I will see you in class.